polymer that we will see in today's lecture. Okay. So first of all, in that very first part is nothing but your identification of plastics. Okay. So suppose someone have give you some like some kind of polymer or polymeric material or plastic material in your hands. Okay. So how you will identify the type of plastics or exactly which kind of plastic material it is? Can you tell by seeing the polymeric material? Can you understand like which
Can
polymer?
see, we can tell PP, we can tell PC, we can tell polycarbonate.
How you can tell that material?
Uh, Polycarbonate, if it is transparent more than 90 percentage, then it is polycarbonate.
Okay, then but how you will understand that part?
It will be more rigid, stiff. It will be more
No, now you are talking about like transparency part, but how you can calculate that transparency?
by looking at that. It will look like a glassy finish.
Yeah, but if you see if you see the PMMA or in that similar way, if you have PMMA with you, the PMMA is also a similar kind of transparency. Then how you can identify the material?
I have seen only PC, sir.
Yes.
I have seen only polycarbonate crystal.
Okay. So that's why I'm asking if someone provide you some plastic material or polymeric material, any kind of, if you are not having that, you can say like transparent plastic, some other plastic you have been provided. So how we will understand that which kind of polymer it is or which polymeric material it is? Do you have that idea with you?
We can burn it. Some plastic will give a ash content. Some will give a. Some will burn. Some will drip. Like that, there are characteristics available. With that, we can say which plastic is for which one.
Okay, that's correct. But then also you will not understand the exact polymer or which polymer you are having in your hand. Okay, so in identification of plastics, there are some basic tests are available from which you can understand the type of plastic material or type of polymer you are having with you. Okay, so for that generally identification is generally dependent when working with plastics there is often need to identify which particular plastic material has been used, correct? Suppose you are using some in some specific application, so means what is the need of identification, that you should know which kind of plastic you are using. Okay, this is essential to get an idea of the cost and likely properties of the product. Okay, the identification of plastic, just a moment. Okay. The identification of plastic is generally very difficult due to what all factors. First of all, it is like the wide range of basic polymers that is available for use. Correct? Means what are challenges to identify the plastic material that are listed here. First of all is nothing but your the wide range of basic polymers. Okay, because many of the polymers are available in market or you can say in commercial aspect. Okay, then second one is like the wide range of additives that can be used to modify the properties of the basic polymers. Correct. Suppose if you are having some A kind of polymer and A and B two both polymers, the A kind of polymers will have some specific properties, but B are not having that properties. But you can modify the B polymer by adding some additives, and you can use it as a you can get the properties as the A polymer. Correct. So if that case happens, then how you will identify the polymeric material, because that both polymers will work similarly, correct? So that's why the wide range of additives that can be used to modify the properties of the basic polymers, it is nothing but the challenge. Then the third one is like the wide range of mixtures of compounds of polymers that can be manufactured to get the required property. Okay, despite this, there are some simple tests that can be carried out to get basic idea of the possible possible polymeric material, or you can say that you can identify the polymeric or polymers using the basic tests. Okay, what all kind of tests are that? So we will see one by one. Okay, so first of all, like what kind of observations you can make by seeing the polymeric material. Okay, in identification by simple method, in which stage one is that, like, if you see the sample, okay, this will give you a lot of information. The color of plastic will give you some information, like one of you have mentioned just now, if it is transparent or not. Correct. So after seeing this kind of observations, like if you are having transparent polymer or transparent plastics, correct? So in that, by observing the polymer, as he has mentioned, like that can be a polycarbonate or polystyrene, or it can be a polyacrylate, correct? So by observing only, you will get the idea. Like if it is a transparent one, then what all kind of transparent plastics or polymeric materials are available, that you will identify, correct? This is nothing but a simpler way. Then the color of plastics, or in that way, some polymers have restricted color ranges, particularly the thermosetting types. Other tend to be glossier in color, like polypropylene, whereas some are both glossy and glassy, correct? Like acrylics. Okay. Then second kind of observation is like the feel of the sample. Like after you have carried out the test in the series a few times, you will start to get the feel for various plastics. Okay. The polyolefins in such a kind, like if you have suppose polyolefins with you, okay, it will have polyolefins have a very distinctive feel, and you can generally tell if it is one of them. Okay, so many of the plastic materials can be identified with the feel, but not all I'm talking about. Okay, then third is like the cut thin sliver from the edge of the sample. By cutting it, like you will get a cut small sliver. Okay, this tells you a lot about the type of plastic you are trying to identify. Okay, this is nothing but a generalized things. Okay, by doing it or by observing it only. Okay, further we are having some tests to get the idea out of it. Okay, first is like cutting test, in which if a shaving can be paired off with knife. If you cut a slice, if you try to cut a slice out of your polymeric material, it may be if it will get cut easily. Okay, or it will get, or whatever the slice if you get by cutting it, then it may be a thermoplastic, correct? Because thermoplastic materials can be cut easily with the help of knife. Okay, but in that also, if you are having polymethyl methacrylate, that is nothing but a PMMA, and polystyrene. Okay, or you can say, if you have remember that we have studied about some brittle polymeric materials. If you are having such a kind of polymeric materials with you, then for that materials it is difficult to cut the parts or cut the slice out of it. Okay, so this is nothing but one of the identification technique, basic identification technique, you can say about it. Okay, then the second thing, if the material is rigid and will not pair off, instead of flakes or instead of the slice you will get a powder, or it will not get cut, it may possibly a thermoset plastic. Okay, if you see the thermoset plastics, correct, if you are having thermoset plastic or thermoset polymer material with you, you can see or you can observe it, like they are hard in nature due to the highly cross-linked structure. Okay, due to the highly cross-linked structure, they are hard, they are not that much flexible like your thermoplastics. Okay, so due to the hard nature or due to the brittle nature or rigid nature, it will not get cut, or you will not get a slice out of it, correct? So from that you can identify whatever the material available with you, or whatever the polymer available with you is type of thermoplastic or thermoset. Okay, hello. So this is nothing but the identification of plastics for the type of plastic, which is nothing but a thermoplastic or thermoset polymeric material. Okay. So next is like hot rod penetration test. Okay. So if you know like if you take some plastic material, okay, or plastic tube, if you if you heat an electronic soldering iron to red hot and press against the unknown sample, okay, like unknown polymeric sample. If the plastic material softens, okay, after pressing the hot penetrating rod, if the plastic material will get soft and the rod penetrates through the sample, okay, after getting soft, your rod will get penetrate into it. So this kind of material will be of your thermoplastic. Okay, because if you know the previous lectures like regarding the thermoplastic and thermoset, what is the property of thermoset? It will We can reshape it by hello, hello,
Yeah, yes, sir, yes, sir. We are
yeah,
listening.
yeah. So if you heat the thermoplastic material, what will happen with it? Yes,
No, if we plastic materials, if we hot rod, if we insert means it will go inside, penetrate
yeah,
inside.
yeah. So if it is so, then it will be your thermoplastic material. But if you see like instead of that, if you are having some thermosetting material with you, okay, then if you do the same thing with that thermosetting plastic, in that your hot rod does not penetrate into your sample, okay, because it will not affect by any kind of heat to change its shape. Okay, its shape will not get changed due to the action of heat. Okay, so in that way you can identify the material again in two types like thermoplastic and thermoset. Okay,
Okay.
yeah. So next is like this is the main basic technique to identify the plastic materials, okay, which is nothing but a flotation test. Okay. If you know all of the polymers having different densities, okay, if you see the density wise polymeric materials, all the polymers have differentiable in their density part. Okay. This test will give the idea to distinguish the material according to their density. Okay. So what kind of thing we can do in this case? So it is nothing but the flotation on different type of liquids. Okay, suppose if you are having water, okay, we can consider first of all the water, okay, as a basic thing or a basic liquid media. Okay, if you try to float your polymers on a water, what is the density of water? Yes,
One.
yeah, it is nothing but a one. The density of water is one. If you are floating polymers with more than one density. So what do you think? It will float or it will get sink?
Think it will sink.
Okay, it will get sink. Or if you are having polymers with density less than one, so it will get float. Correct. So accordingly, you can identify the polymeric materials by knowing the density of its. Okay, by flotation test. Here we have mentioned like different liquids on which you can taste the polymeric granules or polymers by to identify the type of polymers. Like here we are giving alcohol, vegetable oil, water, and glycerin. Okay, if you
Sir,
see,
one of my this thing, I have in zinc magnesium chloride and zinc chloride also they are doing the similar test.
to identify the material or to
Uh,
identify the purity, I think.
no, for floating and sinking only.
Yeah, yeah, yeah. But that you are using as a additives.
Okay, okay, okay. Okay.
In
Yeah.
that, yeah, in that, if suppose that specific material have density more than water, correct,
Yes, sir.
so it will get sink. But if some foreign particles or some other things are mixed with your material
Mm-hmm.
that are having different density, then it will get it can float or it will show different density, correct? So for that they are doing the test,
Like PS, they are
probably.
but, in water it will sink, and chloride, magnesium chloride and zinc chloride, it will float.
Yes, yes. So
Again,
that's why to identify the materials
uh,
over there by using density method or by flotation method, they just check the purity of your material or any kind of some addition have been done by some vendor in that case. Okay. So for that, people are generally using that methods. Okay.
oh,
Yeah. Similarly, you can use the same flotation or you can say density method for determination of your polymeric materials. If you see here, like whatever the LDP, correct? Here LDP as an example we can take. LDP is nothing but the linear density. What?
LDB, linear decimal.
Low density polyethylene, correct?
Yeah, yes.
Okay. So if you see, it will float on water because it is having density less than water. Correct, it is having density I think nearly 0.94 I think. Okay, then if you see the density of polypropylene, correct, polypropylene have density more than your LDP but less than water, that's why it can float on your water. Okay, so if you observe this table you will get idea, like if you are having some specific polymeric material and if you try to float that material on these four type of liquids, so you will get idea that which kind of polymer you are having with you, correct? So this is nothing but a simpler method to identify the polymeric materials or plastic materials, correct? But in this case only you can identify only the virgin polymeric materials like individual, like if you are using LDP then only LDP you can identify using these methods. If your polymers are filled with some if your polymers are filled with some additives or in that way, so obviously its density will get changed, correct? Even if your polymers are in the form of any other, like if you are having polystyrene foam, correct, PS, correct, if you are having polystyrene like thermocol is nothing but your polystyrene again, correct? If you are having thermocol, then obviously that thermocol will get float on your water. Okay, but if you are seeing here in a table in a last row, polystyrene PS is nothing but your polystyrene, correct? Polystyrene, what is the result here? No flotation on water, correct? Due to the density difference, it will sink in your water, correct? But if you take the thermocol, which is nothing but again the polystyrene, okay, it will get float on your water. Okay, so that's why these observations are limited to the virgin polymeric materials only. If you are having some other modifications to it, obviously these results will not get, correct?
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes.
Again, the example I have given here, like the field polyolefins and cellular foams are exceptional for this test. Okay, that's similar, which I have explained. Then again, one of the technique is like the bending test. Okay, in that what we can do in this test is like some plastics will exhibit particularly characteristics in the manner in which they respond to bending. Okay, the bending behavior of some plastics are given in this table. Okay, suppose if you are having polyethylene, correct? If you try to bend the rod or something raw type material of polyethylene, if you try to bend it, it tends to remain. Okay, if you bend it for some time, it tends to remain. Correct. It will regain its shape after some time, but depending on your bending conditions and all. Correct. But accordingly, you can determine it. Then, if you take some polystyrene, correct. If you take polystyrene and if you try to bend it, what will happen? What will happen? As polystyrene is again your brittle type of material, or you can say hard material. Okay, so it will crack. It will start to crack, correct? Then if you have PVC or you can say rigid PVC, it will bends easily and springs back quickly. Okay, then if you are having PMMA is again a hard material. Okay, it will get cracked after bending. Okay. Then if you are having nylon, nylon is having more strength to it. Nylon is having its mechanical strengths are high. That's why it is difficult to bend. Okay. So this kind of bending behavior is having with individual polymeric material. So out of that, if you consider or if you are knowing like bending behavior of polymeric materials, then you can able to understand or you can able to identify the polymeric materials out of it. Okay, by using these kind of techniques. Okay. So next is nothing but the dropping test. Okay. These all are whatever test I am telling you are nothing but the basic test you which you can perform in your labs or in that way. Okay. Because these are the basic tests. It will not require any kind of machinery or what. Okay. So the next is like dropping test. So when a polymer molded compound is dropped on hard surface, okay, if you are having some granules or some suppose plastic ball in your hand, solid ball, okay, if you drop it on a solid surface or hard surface, okay, it creates sound, okay, which shall be either metallic sound or dull sound. On the basis of sound of that polymer is distinguished into two categories, okay. Like if you are having suppose some like PMMA or nylon kind of balls with you, correct? If you are dropping it to on floor, it will sound like a metal. Is it true? Hello, hello, hello. Yeah. So if you are dropping that things on a ground, it will sounds like a metal. Okay. But in that case, if you are having polyethylene or you can say PTFE or PVC. Okay, so if you put or if you drop that kind of materials on a floor, it will sounds dull. Correct. So accordingly, here materials have been segregated in two types. Okay, by which you can identify type of materials. Okay. So next is like somewhat more like after that basic test. This is nothing but some you can say somewhat other technique to identify the plastic material, which is nothing but the burning test, as one of you have mentioned earlier. Like by burning the polymeric granules or polymeric material, we can identify the type of polymers, or we can say polymeric material. Okay. So what we can do or what observations can be happen here in this case, we will see. Okay. So a small sample, if you are held in a flame, small polymeric sample, if you held on a flame, if it ignites, withdraw it from the flame, okay, a distance of flame, make observations as listed below. Okay. So what all kind of observations you can see over that. So if it is self extinguishing, like all kind of observations are like it will get burned or it will get self extinguished. Okay. Self extinguish means it start to burn but it will restrict the flame. It is nothing but does not burn. Okay. then the major then the major observation of burning is nothing but the color of your flame. Okay. Your whatever the flame will get generate after the burning, so you just have to observe the color of that flame, if it is yellow, orange, blue, or blue with yellow, or clear in that way. Okay. So accordingly you can segregate the polymers that I have mentioned in next slides, like which color will show you which kind of polymer. Okay. Then type of flames. Okay. Like if your flame is steady or if your flame is like tall, short, or sputtering. Okay. Then type of smoke, then melt behavior of your polymeric material, and last one observation is nothing but your odor. Odor is nothing but your smell of your burning. Okay. So by observing these all things, you will understand. See, The typical results of burning tests of polymers, specifically for thermoplastics, are given here in this table. Okay. Suppose if you are considering, suppose if someone gives you the polyethylene with you, okay, if you try to burn it, okay, what kind of melting behavior it will show? It will melt and bubbles fiercely around the edges, okay, and it start to drip. Whatever the bubbles will get created out of it, it will try to drip down. Okay, so this is nothing but the melting behavior of your polyethylene after burning. Then color of flame, which kind of color it will give? Blue base with yellow tip. This kind of flame will be provided by your polyethylene material. Then order is nothing but your waxy or burning candle order. Okay, then such a kind of observations have been given here for different type of polymeric materials. Okay, by which you can able to identify the type of polymeric material, okay, by burning the polymers. Okay, for individual polymer we have mentioned here the observations. Okay, now that observations are generally for the thermoplastic which we have mentioned in recent slides. Okay, but if you are having thermoset material, then which kind of observations you will get? If you are having phenolic resin, or you can consider here like phenol formaldehyde resin, then which kind of color to your flame will get? Okay, and which kind of smoke you will get? It is nothing but you will get the yellow flame and self extinguishing property. Okay, like if you try to burn the phenol formaldehyde resin or phenol formaldehyde plastic, so it will try to extinguish the flame, means it will try to minimize the flame or stop the flame, which is nothing but the self extinguishing property. Okay, this smell is nothing but the charcoal type of smell you will get out of it. Okay, then similarly you can identify the same observations in case of your elastomers or rubbers, you can say. Okay, then next technique of identification of polymer is nothing but the pyrolysis test. Okay, whatever the test I have mentioned here, it is nothing but somewhat advanced technique. Okay, than your basic one which we have studied here. Okay, the next is like pyrolysis test. In this testing, heat we have to we generally heat the polymeric systems, or we generally heat the some milligrams of polymer of the sample in an ignition tube, or we can say, and taste the pyrolytic vapor with a moisture indicator paper. Okay, the behavior of vapor to indicator paper is given as follows. Okay, if if that vapors contain acid, obviously your it will turn the blue litmus to red. If it is basic, it will turn red litmus to blue. Okay, what kind of or which polymers will create the acidic vapors? So acidic vapors can be created by it may come from carbohydrate polymers and their derivatives like cellulose acetate. Okay, if you try to burn cellulose acetate, so acid vapors came out of it. Okay, and that can be identified by your litmus paper. Okay, suppose high acid vapors or acidity of vapors is more, then what kind of materials it can have? Often indicate the presence of chlorine, example like PVC or rubber natural vapors. Okay, rubber neutral vapors evolved from hydrocarbon polymers, silicons, and some polyester hydrochlorides. Okay, this is nothing but the other observation. If high acid vapors will get, the polymers will be like PVC or hydrocarbon polymers or silicons. Okay, then if you will get the alkaline vapors, or you can say it a basic vapors. Okay, if your litmus paper will turn red litmus turn into blue, then it will be your alkaline vapors. It will indicate the presence of nitrogen, example like polyamide proteins and amino formaldehyde resins. Okay, so this is nothing but some of the observations which generally been obtained from your pyrolysis test. Have you understand this? Hello. Hello.
Sir, in this,
Yes.
any particle we have to cut and put in a test tube and it has to be heated, huh?
Yeah, a special kind of tubes are available, okay, for the pyrolysis test. It is not a test tube, okay. Pyrolysis test, special kind of tubes are been there. In that, only few milligrams of your polymeric samples you can insert, okay.
Okay.
After inserting, if you heat the tube or in ignition, okay, some pyrolytic vapors will get created, okay, and that vapors with moisturized indicator paper will show you the
Is the indicator paper will be in moisture content like our recent days, this tissue papers are coming wet, no? Wet tissue paper, like
yes,
that?
yes, yes. In that, not fully weighted papers. That's
Uh,
why I have mentioned here the moisture indicator paper.
it
Okay.
is not that we have to dip in water and keep, no?
No, 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 no. Not in that case. Not in that way. Okay. Yes. So out of getting these observations of acidity and basicity, you will know that which kind of polymer it is. Okay. Then specific gravity test. Okay. So again, if you have observed like in flotation test, correct? In flotation test, what we have observed is your material is floating on water or not, or it is floating on water or sinking in water, correct? Okay. So similarly, specific gravity test is there. A simple test for differentiating between your different type of plastics, which can be carried out by placing specimen in water. Okay. Some will sink and some will get float depending on their specific gravity. Okay. As mentioned in the table. Okay. Like as I have told you, like specific gravity of your polypropylene is nothing but 0.9. Okay. Which is less than your water. Like water is having one. Okay. So it will get float over it. So what all kind of materials will get float? Polypropylene, low density polyethylene, high density polyethylene, okay, which are having less specific gravity than your water. So which all kind of materials will get seen? That are nothing but your polystyrene. As I have told, the polystyrene is having density or specific gravity more than 1, which is nothing but 1.07. So that kind of polystyrene can be sink in your water. Okay. So those with the higher specific gravity will sink as shown in the table. Okay, accurate specific gravity results can be obtained by the standard method of relating weight of the material to weight of the water displaced. Okay, so this is nothing but the specific gravity test to identify the polymeric material. Okay, is there any doubt?
No, sir.
Okay,
Sir, one doubt, when
yes,
the weight is very low, how can we check this density in the densimeter?
it is not like a densimeter, but if
You know,
weight,
weight in air we can see, but weight in water, it is going to float. So,
yes,
see,
see, it is depending on your density, not weight. Obviously your density will dependent on your weight of the polymeric system, correct?
okay,
Okay, so if the density of your polymer is less than 1, okay, 1 is the density of your water, correct?
yeah, yes,
If it is less than 1, obviously it will get float on your water.
yeah,
Okay,
yes,
but if the density is more than 1, then it will get sink.
understood. If it is more than one, checking in a
Yes,
densometer for this thing is understood.
yes, yes.
Because let's say it is when it is floating, we cannot able to check the density of that, the weight of that in water. In
No,
that case, what
no.
is the methodology to check?
Yeah, in water obviously you can't check the weight of your sample.
Okay, so if zero point 0.9 is there for PP, so specific gravity, it is only a representative value. We cannot check the density or specific gravity, right?
Yes.
Okay, sir. Okay.
So next is like one more test is there, solubility test you can say here. Okay. So as you have studied earlier, the different type of polymeric materials, correct? Different type of polymers you have studied over here. Okay. So every type of polymeric material. will get dissolved in different solvents. Okay, as now, like if you see your PVC, correct? PVC is dissolving in some special kind of solvent. It is nothing but you can call it as a cyclohexanol. Okay, cyclohexanol is nothing but a solvent for your PVC. Okay, so every polymer have its solubility in different solvents. Okay, so solubility test form a basic of some older identifications techniques. Okay, mainly the type of plastic. However, in many cases, solubility varies considerably for different samples of the same resin. Okay, then it is difficult to interpret the results. Okay, solubility of plastics may vary according to the grade or to the whether or not other constituents are present in the sample. Okay, so if you see, like if you see the table here, we have presented like which all plastic materials are getting soluble in the solvents or kind of solvents. If you see here, like if you are having polyamides with you, okay, polyamides is nothing but your nylon and all that kind of polymers. Okay, so that polyamides generally solubilize in your phenols, then formic acids. If you see here, okay, phenols, formic acid, or tetrafluoropropanol. Okay, this kind of solvents are generally used to solubilize your polyamides. Okay, if you see polystyrene, okay, polystyrene is generally soluble in your aromatic and fluorinated hydrocarbons, or you can say pyridine, then ethyl acetate. Okay, these kind of solvents can be used to soluble the polystyrenes. So this technique is generally used dependent on the solubility of your plastic material. Okay, so next is like softening and melting points of your polymers. Okay, obviously if you have seen in many applications of polymers, okay, or many polymers, type of polymers, they are having different melting point range, correct? If you have suppose some polyethylene, okay, if you are having polyethylene and polypropylene, okay, so obviously the melting point range is different for both of them. Polyethylene is having low melting point than your polypropylene, correct? So by identifying the melting point or melting uh, or softening point of your polymeric material, you out of that you can identify the type of polymer, correct? Hello, hello. So what is the procedure to identify the softening and melting points of the polymer? Okay, in that we generally take like place the 2 to 3 milligram of milligram portion of your clean glass slide and cover with number one cover glass, then heat the slide. Okay, the sample and cover on a hot plate to slightly above the softening point of the polymer so that a thin film can be formed. Okay, by by slightly pressure on the cover glass, form a thin film. Okay, after pressing two glass plates, if you are placing suppose some polymeric sample in two glass plates, and if you try to heat it, okay, it will get soft and will get form a film out of it. Okay, keep the slide on a hot plate, melting point apparatus. So you will get, if you adjust the hot plate temperature about 10 degrees Celsius below the melting point of sample, okay, you have to adjust the temperature accordingly. Then adjust the temperature ramp at zero point 0.5 degrees Celsius per minute. Okay. Then if you observe the increase in temperature at 1, you will see that your polymer is, or whatever the polymer melt is flowing, correct? So at the start, if you means in this whole process you will get the range, correct, range of melting point. Okay, so over there you can find out your polymeric melting point. Okay, so in this table I have mentioned like different softening points of your polymeric material and melting point, correct? So if you see HDP over here, what is the softening point for HDPE? It is nothing but the 120 degrees Celsius, and melting point is 130 degrees Celsius. While as we have to example of polypropylene, correct? So polypropylene is having more the melting point more than your polyethylene, or nothing but the HDP. Okay, like HDP is having melting point around 130, while the polypropylene is having melting point around 165 to 170 degrees Celsius. Okay, so these melting points will differentiate your polymers. Okay, by knowing the melting point, you can identify your type of polymer. Okay, hello,
Slide, I have a doubt, sir.
yes,
Softening in previous slide.
yes,
Here, you told it's like some two plate we have to keep plastic.
yeah. See, the procedure is for determination of your melting point.
Okay, it is other than DSC, this is another method.
Yeah, it is general, you can say basic method. DSC is appropriate method.
Okay, but here you told the surface only has to be heated. Huh?
Yes.
Then keeping the other plate, what it will happen, sir?
You have to keep your sample in between the two glass slides.
Okay, that glass cover is the part of a machine instrument. Huh?
Yes, yes, yes.
Okay, in between the two, we have to keep it. When we
Yes.
keep it, what happens? Point zero
We
one.
will after that by placing it means after softening the polymeric system, we will increase the temperature, okay, by some speed. Here we have mentioned like 0.5 degrees Celsius per minute. Okay. So after increasing the temperature at one point, your plastic will start to melt. Correct? That we can observe. Okay, from that your melting point will get start. Okay, and at one temperature your plastic will be in a complete molten form. See,
Okay,
if you see here, in many of the polymeric system, there have been mentioned the range of melting point. Correct?
okay, okay.
Yeah.
Okay, it starts melting and till it is completely liquid form.
It is not, we can't say it is in a liquid form. We can say it a molten form.
Okay, till complete, but complete material should become molten. Still that
Yes.
time it is heating.
Yes, yes.
Which particular value we will take as the melting point, starting or till the end?
This is generally the range. We can't say like that only one.
No, no. There is a one point where it's like considering if I assume like an ice, the ice starts melt from the top. So should I
Yes.
start from that as melting point or till the
No, no,
complete
no, no.
melted I will?
See, in case of that, whatever the examples you have mentioned, we can consider a single point. If you see, like if you taste same sample on DSC you will get a single melting point, correct?
Yeah, yes.
Yeah. Okay. So there you will get, but in this case, you will get the range of melting temperature, because this is the basic testing to get the melting point.
Understood, sir. Range means it is start point and end.
Yes, yes. In the from this testing, you can't say like that, "Ki this is the exact melting point of your polymer." You always will, this will always provide you the range. Okay.
Okay, and once it is over, crystallization we cannot check here. There is no.
No, 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 no. That we can check only through the DSC.
Okay, so here it
Yeah.
stops with
It
this
is
one.
only for the melting point.
And it is in room temperature, there is no nitrogen gas.
No.
Okay, sir. Okay, understood.
That's why it is a basic technique. Okay.
Understood, sir. And what will be the accuracy difference between DSC and this one?
There is a, you can say much gap is there, because DSC is much accurate than this.
10-degree difference can be there or 5
No, no,
degree?
no. It is not like much difference is there. Like if you are having the range of polypropylene like 165 to 170, you will get in between the in what are the temperature in between this, or nearly 170, you can say. Okay. So range is not like that. Okay.
Uh,
Whatever you are telling.
understood, understood.
Okay.
Thank you, sir.
So then, some of the confirmation tests are there, as earlier we have mentioned, like burning tests are there, correct? In that burning test, we have mentioned color of flame, correct? Color of flame and some other observations have been mentioned in your in that tables, correct? So here are for some specific polymeric systems, we have given some confirmation test. Okay, first of all, like for thermoplastic, so one is like test for polyolefins. Okay, so for polyolefins, just okay. So first of all, like for polyolefins, okay, a piece of dry sample is pyrolyzed, like we have mentioned in our earlier slides. Okay, pyrolyzed. Then in the tube closed with filter paper, which is drenched with a solution of zero point 0.5 gram of yellow mercury oxide in sulfuric acid. Okay, this is nothing but a chemical formulation used to identify the type of material. If the vapor gives a golden yellow spot, okay, it indicates polyisobutylene or butyl rubber and polypropylene. Okay, the latter only after a few minutes. Okay, polyethylene does not react. Natural and nitrile rubber as well as polybutadiene yields a brown spot. Okay, so these are the some confirmation tests which are available for each type of plastics. Okay, this is nothing but one of the example I have shown you here, like during the pyrolysis process, as we have mentioned in recent slides. Okay, so if you use this kind of technique, you will get some colored spot out of it, means after burning the polymer. So after observing this color spot, you will identify the type of polymer. Okay, yes. So these are nothing but the confirmation tests generally available for identify the thermoplastic and thermostatic materials. Then if you see next is like the test for chlorine containing polymers. Which one is chlorine containing polymer here? Which chlorine containing polymer you are knowing about? Yes. Do you know about polyvinyl chloride?
Yeah, yeah.
PVC? Yeah.
See.
PVC is nothing but the chlorine containing polymer. So how you can identify if you are giving PVC and you are not knowing that that polymer is PVC, then how you will understand that? You will do the copper wire test. Take a piece of copper wire about 5 mm long, push on end of the wire in a two small core. Place one pellet or a plastic sample near your burner. Okay, this is the sample you will be testing. Okay, hold the free end of the copper wire in the burner, or we can say flame, until it is red hot and the flame no longer has been green color. Okay, so remove the wire from the flame and torch the hot wire to the plastic pellet of your PVC. Okay, or sample you will be testing. So a small amount of the plastic should melt onto the wire, correct? After after inserting that hot red copper wire on your plastic material, obviously that plastic material will get melt and it will be on your wire. Okay, so place the end of the wire with small amount of plastic on it into the flame. You should see that slight flash of a luminous flame. Luminous type of flame will get with yellow orange color. If the flame turns green in color, then the sample contains chlorine. Okay, have you understand this part? Hello. How to identify the chlorine containing polymers, or you can say polyvinyl chloride.
Has to be that cork means it is some specimen, does it?
Cork means some rubber that to hold the wire.
Okay, so it is only a holder. So
Yeah, holder you can consider.
then pallet of plastic near the buns, buns and
Burner, nothing but the flame.
okay, it's a flame.
Yeah,
Will be tested. Then free end of copper wire to be burnt. Okay, it's a 5 mm means how much long? Length itself is 5 mm.
Yes, it is a
Then
half cent. Yeah.
the other end has to be heated. Huh? One end has to
Yes.
be heated, the other end we will be
Yes.
touching the plastic surface.
Yes. Yes. Okay. So after means melting the polymer on your that wire, if you
Okay.
start burning, if you start again providing flame to it, you should see a slight flash of luminous flame. Okay. If the flame turns green, okay, after that yellow orange color, it turns to green.
How the
So
are in this?
yes,
How that copper rod is heated because it is 5 mm longer. So in the burner, if we heat means that heat will transfer to our plastic also. No?
yes,
Slowly.
yes. That is the purpose. The heat should transfer to the plastic. What
Not
which we
also
have to test.
understood, sir. If it is transferred through the wire, then it is right. But it can directly touch the plastic also, no? Because it's a flame.
That is the purpose. If you see, like, see, remove the wire from the flame first, okay? Then a small amount of plastic should melt onto the wire, okay? So on your wire now, small amount of plastic is there. Then place the end of the wire with small amount of plastic on it into the flame again. If you see the last point,
Okay,
okay?
okay.
So into the flame,
It's like
you
soft.
should,
We have to
yes,
touch the material lightly. Then
yeah,
again, we have to take to the touch.
yes, yes. Okay,
Okay.
if you in that flame, firstly you will get the yellow orange color luminescence flame. Okay, if that flame will turn into green, then it is nothing but the identification of your chlorine containing polymer.
So
Okay,
first some material will burn. Second, this chlorine material when burns, then this green color comes. It's like that.
yes, yes, yes.
Okay, okay,
Okay,
sir.
so this kind of identification or confirmation tests are been there to identify the different type of polymeric materials. Okay, so we will take a 5 minute break and we will meet again. Okay. Is
Okay,
it
sir.
okay to all of you?
Okay, sir.
Yeah. Thank you. Hello, hello. Okay, so we will restart the lecture. Okay, everyone, can you able to see my slides? Hello.
Yes, sir.
Yeah. Am I clearly audible to all of you?
Yes, sir. Yes, sir. You're
Yeah,
audible.
yeah. So we'll continue with our confirmation test part. Okay. Now, as of now, we have seen for thermoplastic materials. Okay, thermoplastic materials, or you can say chlorine-containing polymers. Okay, as now in last slide we have mentioned it like chlorine-containing polymers. Now we'll move toward the how we can identify the thermoset plastics or thermoset polymers using the confirmation test. So we will take two examples over here. One is like test for melamine formaldehyde resin. Okay, in amino resins, correct. If you are remembering the lecture, I have only took the lecture of yours like amino resins or aminoplastics. Have you remember that aminoplastics? Yes. We have conduct one lecture on aminoplastics. Okay, in that we have studied three to four polymeric materials, including melamine formaldehyde, urea formaldehyde. Okay, one of like in phenolics, phenol formaldehyde. These two to three type of polymers we have studied. Okay, out of it, one type is like melamine formaldehyde resin, which is nothing but MF in short form. Okay, so how we can identify that this material is melamine formaldehyde? By knowing the melamine part out of it. Okay. For that, what we can do here is the procedure like about zero point 0.5 gram of sample is refluxed with 80% acetic acid. Okay. For 30 minutes, then cooled and filtered it. Then the filtrate is evaporated to dryness and added 2 ml of water, cooled and filtered again. Okay. To the filtrate, one drop of saturated aqueous picric acid is added. Okay. Yellow precipitate indicates the presence of melamine. Okay, if if we will get the yellow color precipitate after doing this experimentation in your container, then your polymer containing melamine part. Okay, this is nothing but a chemical procedure to identify the melamine, means if there is a presence of melamine in your polymeric system or not. Okay, have you understand?
Yes, sir.
Yeah. So next is like all of you know about the epoxy, correct? Epoxy resin or epoxy polymer. So how you can identify the resin given to you is epoxy or not? Okay. There is a test or you can say confirmation test for identification of epoxy resin, which generally called as a four-crime method or four-crime test. Okay, about 0.25 gram of sample or resin sample you can take or you can dissolve it in a 98% H2SO4. It is nothing but the sulfuric acid. Okay, by slight warming. Okay, after cooling 1 ml of 63% HNO3, this all whatever the chemicals are here mentioned are nothing but the acids. Okay, H2SO4, HNO3 are the acids. Okay, then after shaking, the mixture is poured into 100 ml of 5% aqueous NaOH. Okay. By doing so, if a bright red or orange red color if you get, then it is indicating that the presence of epoxy resin. Okay. So after doing this chemical experimentation on your resin, if you get the bright red or orange red color of your liquid, then there is a presence of your epoxy resin. Okay. Hello. Yes.
Yeah, yes, yes.
Yeah.
It's in this 0.25 grams we are adding.
Yeah, 0.25 grams of your sample, resin sample you can consider.
And aqueous NaOH is brightener, huh?
NaOH is nothing but the basic solution, or you can say caustic.
Okay.
Okay.
Acids are high in content and
Yes,
alcohol
first acid is your sulfuric acid, which is nothing but 98%. concentration. Then second is your amino acid, okay, HNO3, okay.
63%, but 5% aqueous NaOH is sodium.
Sodium hydroxide.
It is added in water.
Yes,
5% it's water solution.
yes.
Okay. It's only titration type. We have to add.
It is not a titration type. You can directly keep these all things in a single beaker or a container to identify the resin.
How much time it will
In
get this color change? How much time it will take? Because
it will take 4 to 5 minutes only. Means after addition of each thing, just you have to mix it properly by shaking. Okay.
so stirring.
After whatever the all materials we have added, if we after getting reacted, means after getting whole reaction completed, okay. After that you will get the color.
Okay. So after in acid it gets dissolved. First material is getting
Yeah,
dissolved.
yeah, yeah, yeah.
Okay. Okay, sir. Okay. So previous slide, please. Here it is. Here it is not titration type. Here it is
No,
only
no. It is also the similar thing. Okay.
acid is getting dissolved.
Yes, yes.
But 30 after 30
But
minutes.
in this case, you will get the precipitated product in a yellow color. Okay, which indicates the presence of melamine.
Okay, it is in precipitation form.
Yeah.
Okay. And here also 2 ml of water. But here cooled and filtered, then
Yeah,
filtered.
due to the reaction conditions, whatever the reaction conditions means, if it is a exothermic reaction, it will create heat. To cool down the reaction, they are adding some amount of water. Okay.
Okay, so for here it is, here also it is only acid. It is getting mixed in the acid. After that,
Yeah.
to cool it for some time, then automatically precipitation comes after 30 minutes.
Yeah.
Okay, sir.
Okay. So again, there are some testings for rubber. Okay, for identification of rubbers or type of rubbers. Okay, there are some test procedures. Okay, so in that also, if you see like to test the rubber or to identify the rubber, you have to heat the rubber sample strongly, or you can take a zero point 0.5 gram of sample. Okay, heat it strongly in a test tube until sample begin to decompose. Okay, and pass the fume in solution 2 and 1. All solutions have been prepared, like if, you are given here the two solutions. Okay, then again, as per the last slides, as we have prepared some different solutions for testing, here also to test the rubber samples, we have prepared two different solutions. Okay, after passing that fumes through the solutions and observe the change in color. Okay, if you observe the change in color, if initially pale yellow color, after heating will get pale yellow. Okay, in solution 1, and in if same in solution 2, if you get the green, then your this is for your blank solution without rubber. Okay, but with rubber, initially in solution 1 yellow, then pale yellow, green to red. In solution 2, it will be your chlorinated rubber. Okay, Cr. Okay, so such a kind of observations of change in color in solutions. Okay, first of all, what they have done here, they have burned the polymer or burn the rubber in test tube. Okay, to the decomposition of your rubber. After decomposition, some fumes will get created, and that fumes will pass through the solutions which we have prepared here. After passing the fumes through the solution, the color will get changed, and out of that color, by observing that color, you will get to know like which rubber is present or which rubber is there for as a sample. Okay. Yes. So
Minutes.
this is nothing but the test for your the identification of rubber samples. Yes.
Just reading it, sir. Sorry.
Okay. So next is like, have you understand this part?
1 minute, sir. 1 minute. Sir.
Okay, so we'll move forward for the next identification technique. Okay, of the
Point,
polymer. Yes.
in this 0.5 grams we are taking and we are dipping in some solution. After that, again, dimethyl amino benzyl, that 5 ml we are adding in this. It is like continuous, we have to do this. Huh? First
No.
time,
See. If you are having rubber sample with you, okay.
uh,
So we will just shortly explain this part. Okay. Primarily, we will prepare two type of solutions. Okay, solution one and solution two, as we have presented in slides. Correct. So
okay,
in solution one, we have to dissolve 1 gram of para dimethyl amino benzaldehyde. This is nothing but a type of chemical. Okay, this chemical, 1 gram of this chemical in 5 ml of HCl and add 10 ml of ethylene glycol. Okay, then adjust the density to 0.851 gram per cc by addition of methanol. By
okay,
doing this, you will get the solution one. Okay, similarly, you will get the solution two. Okay, these two solution we will prepare already.
okay. So this is
Okay.
yellow, pale yellow, and green is the color of solution.
Yes. See, these solutions, if you like, see, if you are having two beakers, okay, in two beakers, out of these two solution, we will take two solutions in two beakers, correct? And after burning your rubber, whatever the fumes will get generated, that fumes we will pass through one by one, like in first solution, then in second solution. Okay, by passing in first solution, if you are having suppose SBR, styrene butadiene rubber, okay,
Okay,
we will burn that SBR. Okay, after burning, after decomposing, some fumes will get created. That fumes we will pass through solution one. Okay,
okay,
after passing in solution view, initially it will show yellow green color. Okay,
okay,
after heating, after heating to that solution, you will get a green color.
okay.
Okay, these are the observations for in your solution one. Okay, similarly, if that fumes you will pass through the solution two, you will get the green color.
Understood, sir. And
Okay,
solution two is that whatever written is the preparation of solution one.
yeah. It is
Solution.
nothing but the dissolved 2 gram of sodium citrate, 200 gram of, 200 milligram of citric acid, then 300 milligram of bromocresol green, and then 300 mg of methanol yellow, okay, in 500 ml of water. This is
And,
nothing but your solution 2. zero
and this 0.5 gram is heated
point
and
0.5 gram is your rubber.
rubber. For solution one, to pass the gas in solution one, we need 0.5 grams, and for solution two, another 0.5 grams.
Yeah, whatever. Yeah, yeah.
Uh, my understanding is right now, sir.
Yes.
Okay, understood.
Okay. So next, the last one is like identification of plastics by its identification code, as I have mentioned in polyester lecture. Okay, if you are remembering or not, I don't know, but in polyester, I have mentioned this triangle with one number for pet. Have you remember that thing? I have told you something to find out, like you have to find out plastic components or plastic uh, containers behind you or around you, on which these kind of symbols have been mentioned over there.
Correct,
Have
sir.
you seen that?
Yeah, in second or third class, the complete 1 to 7, it was explained with different colors also.
Yes, yes,
From
yes,
the
yes.
materials.
So that is nothing but the to easily identify the plastic materials. These are nothing but the commonly used plastic materials. These codes are generally only given to the commonly used plastic materials, not for all plastic materials. Okay, only for six type of plastic materials these codes have been provided. One is like polyethylene terephthalate, which is nothing but the PET. Then second is the high density polyethylene, which is nothing but your HDPE. Then three number has been provided to your PVC, which is nothing but a polyvinyl chloride. Okay. Four number is for LDPE. Fifth is for your PP, it is nothing but polypropylene. And six is for polystyrene. Okay. This is nothing but the identification codes for your plastic materials, or you can say commonly used plastic materials. Okay. Yes. By
Yes,
seeing this number on some plastic container or plastic article, you will identify the type of plastic. Okay.
yes, sir. Yes, sir.
Yeah. So next is like mechanical properties. Okay. Mechanical properties of your polymeric material. Okay. What all kind of mechanical properties do you know about till now? Have you seen any mechanical properties of polymer or plastic?
Heat deflection,
Yes. Heat deflection is nothing but the thermal property.
thermal property. Then notch test.
Yeah, notch is nothing but is notch tester is to create notch on your polymeric uh, that article, which generally used to determine the mechanical properties itself. Okay.
Then tensile and elongation,
Yes, tensile, elongation, these all are your mechanical properties of your plastic or polymeric material. Okay.
elastic property also mentioned.
Yes, yes. So till now we learned about the identification of polymeric materials, correct? All of you understood the part that is
Yes,
identification of polymeric material.
yes, sir. Yes, sir.
Do you have any doubt in that part of identification of polymer? Yes,
No,
because
sir.
we are moving forward for the next part of polymeric testing. Okay, these are the basic testings or somewhat somehow like whatever the pyrolysis we have used, some advanced techniques to identify the polymeric material. Okay, so we will now move forward for the properties, how to identify the properties of polymeric material. Okay. So there are many testings have been available in polymeric field to identify the properties of like mechanical properties, thermal properties, electrical properties, then your optical properties of polymer. Okay, flammability properties. Such a kind of properties polymeric materials are generally having. So to understand or to identify or to measure the properties of polymer, okay, we are having some type of testings. Okay, that testings we will see. Okay, so first class of properties is nothing but the mechanical properties of polymer. Okay, in which what all kind of properties have been there. So first is nothing but your flexural test. Okay, so very first mechanical property for polymeric system is your flexural test. Have you heard about flexural test before? Yes. Hello. 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 Hello.
Yes, sir. Yes, sir.
Have you heard about flexural test before?
Yeah, yes, sir.
What happened in this test?
Uh, 3 point this thing
Yes, 3 point or
two.
bending test you can say.
It's like a
Correct.
bit.
It is
Uh,
nothing but the bending test.
uh,
Okay. It's again classified into two types, 3 point bending and 4 point bending. So let's see the flexural test here. Okay. Flexural test is nothing but a type of destructive test, or you can type of testing. Okay. Flexure or bending characterizes the behavior of slender structure element subjected to an external load applied perpendicular to a longitudinal axis of the test specimen. Okay. If you are having like I have mentioned some images after this slide. Okay. Typical material tested on this type of test is nothing but the polymers, wood, composites, or the brittle materials. Okay. So we are interested in polymers only. Okay. So here you can see the test method or the presentation of this test method. So first in your left hand side, it is nothing but the 3 point bending. So can you see this cursor, red cursor here.
Yes, sir. Yes, sir.
Okay, so this is one point. This is the second point. Okay, these two are the stationary points. Okay, or you can say non-movable points. Okay, so on this non-movable point, your test piece or test specimen have been kept. Okay, this is nothing but your polymeric specimen. Okay, or you can say strip. Okay, so on this strip, if you this strip have been kept on these two non-movable points. Okay, and the third point, third movable, okay, or mobile, third mobile point have been kept on your center part of your specimen. Okay, have you seen this? Can you observe this?
Yes,
Yes.
sir.
Okay, so this is nothing but the movable part. On this movable part, we are going to apply some force. Okay, like this. Have you seen here? This is nothing but the application of force through this moving part. Okay, this is nothing but the indenter, we can call it as a. Okay, so as we apply the force on this this will start to bend from this side, correct? Okay, this is nothing but the flexural test of 3 point type. Okay, similarly you can observe here 4 point bending here. Okay, what happened in 4 point bending? These two stationary points are there and two moving points we have shown in a blue color. Okay, so at these 2 points we are applying force in a downward direction to bend the specimen. Okay, so this is nothing but the 4 point bending. Are you getting it?
Yes, sir. Yes,
Yes.
sir.
Okay, this is nothing but the general representation of your 3 point bending and 4 point bending. Okay,
Yes, sir.
yeah. So again, if you we will see in some detail. Okay, okay, we will see in some detail why to do this test. Why people are generally doing this test for polymers. Okay, why we are doing this test for polymers? What kind of property we will get out of it? What do you think? So procedure is nothing but the tensile stress in the convex side of the specimen, compression stress in the concave side. Okay, so useful to select material for parts that will support load without flexing. Okay, if you are having some application, okay, if you are having some application in which loads have been applied over your polymeric material, correct? Okay, so in that case, the whatever the load you are applying, that load should not bend your polymeric material, correct? So that's why you have to test your polymeric material with this kind of test. Are you getting this?
Yes,
Why
sir.
we are using this testing? Okay, so used as an indication of a material stiffness when flexed, this creates an area of shear stress along with the midline. Okay, to ensure the primary failure comes from tensile or compression stress, the shear stress must be minimized. Okay, so why we do this test? Why to do this test? Have you understand that part? Why is require what is the requirement of doing this test? Okay, so next is like here you can see how that test will get performed. Have you seen the movement of the force?
Yes, sir.
Okay, this how your test will get performed on your 3 point bending. Force will get applied to center. Your part will get fold or it will get bent through the center, and whatever the amount of force is required, that can be measured. Okay, till what point we will apply the force? Till rupture or deflection, until the rupture occurs in your specimen. Okay, see here you will observe this is also a general representation. If you see here, can you able to see this? Force is getting applied and your specimen, this white color specimen, is getting bended. Can you see this?
Yes, sir.
See, from here force is getting applying and your specimen is getting bended. Correct?
Yes.
Yeah. This is nothing but your 3-point bending test. Okay?
But up to when this has to be done,
Yeah.
whether
It is again, it is,
or
hello.
or needs it.
Yeah, it is again dependent on your polymeric material and type of application. Some people are doing this test till the rupture of or to the breakdown of your polymeric system, and some are done it till the complete bending. Okay, it is depending. It is fully depending upon the application or the where it means like where you have to apply that polymeric system. Okay.
Okay.
So loading noses and supports, here are the parts of that instrument should have cylindrical supports and noses. This is nothing but a cylindrical. If you see the portion by which we are applying the force or by which it supports the specimen, that are circular. Can you observe this? These are the cylindrical portions which support the noses. Radii of both the means radius of the both should be 5 mm or plus minus 1 zero point 0.1 mm. Okay. Maximum radius of the loading nose shall be no more than 4 times of the specimen depth. Okay. These are the requirement of your specimen size as well as the noses. Okay.
Yes, sir.
Okay. So what kind of test specimens have been used to test this kind of to testing? Okay. So here we have mentioned the specification of sample. Okay, so your sample should have 50.8 mm in length, 12.7 mm in width, and height is nearly or nearly like 1.6 mm. Okay, so this is according to the standards. Okay,
Is it ASTM standard or some other standard, sir?
see, this is according to ASTM standard, but if you refer other standards as well, ISO standard or something other standard, they are providing some different sizes of it. Okay,
Okay.
depending on your standard, the size will get changed slightly. Okay.
Mhm.
So what is the test procedure over here? Okay. So in that, as you have asked, till what point we can test the specimen, correct?
Yeah, yes.
So first is like in procedure A, when we can terminate the test, that is given here, like maximum strain in the outer surface of the test specimen has reached to 0.05 mm per mm or inch per inch, or at break if break occurs prior to reaching the maximum strain. Okay. Then second is like when we can terminate the test at break if break occurs prior to reaching the maximum strain. Okay. Maximum strain in the outer surface of the test specimen. Okay. These these two conditions are generally for, first is for brittle materials and second is for flexible materials. Okay. So
Strain,
how
strain is, will it be visible?
you will get the stress strain curve on your graph.
Okay,
Okay.
understood.
Yeah. One
But,
machine is there, UTM. UTM, all of you know about universal testing machine.
yeah, yes.
Yeah. Load cells are there. Correct. So that load cells will give the readings. Okay. The readings of your strain, out of which you can understand the distribution of strain. Okay.
Understood.
Here you can observe the distribution of bending moment and the shear force in flexural test. Okay. If you see in the very first picture, okay, you will see both type of bending, 3-point bending and 4-point bending. In 3-point bending, distribution of your shear force you can observe in graph. Okay. As well in 4-point bending. Okay. So what all specifications and applications of this test is there? This test is used mostly in quality control and specification purposes. Again, the materials that do not fail by the maximum strain allowed. Okay. Then the location of the maximum bending moment and maximum axial fiber stresses is different in 3-point and 4-point bending. Obviously, because if you are using these two methods for same sample, then the bending moment and maximum axial fiber stress are different for both the testing methods. Okay. The maximum axial fiber stress occurs on a first is like line under the loading nose in 3-point bending. Okay, as we have mentioned here, you can see the maximum stress. See, can you see this cursor? Okay, maximum stress in 3-point bending is observed in a center, correct? While in 4-point bending, the maximum load is observed at these 2 points, correct?
Where to use 3-point and where to use 4-point method?
Correct. It is again depending on your application. Okay, suppose as we are taking only the applications of your polymers here, correct? Okay. Now you can consider if I suppose give you the one example. Have you seen the bridge, overhead bridge,
Yeah, yes, sir.
flyover bridge,
Yeah, yes.
correct? That flyover, if you suppose consider the portion in between the two columns, okay, there are many columns to hold that bridge, correct?
Yeah,
If you
yes.
only consider two columns, okay,
Okay.
that how that two how the forces means how the capacity of that bridge can be calculated, correct?
Hmm,
The
hmm.
similar concept you can apply here. If you are having 2 points over here, like two columns over here to support your bridge, correct, and you are applying the vehicle load or whatever the load on the bridge, okay,
Uh,
if you are applying load at a center, then
hmm.
what kind of bending can occur? And if you are applying load on these 2 points, then what kind of bending can occur? Okay. So these kind of calculations have been done in case of bridge as well.
Whether
Okay.
any it's based on the customer requirement. Is
Yes,
there
yes, yes.
available?
Is based on the customer requirement as well as the requirement of specific applications.
Only application based. Okay, sir.
Okay. So now the part is clear to all of you.
Whether customer will specify a flexural by 3-point, flexural by 4-point, like that, it will be
Yeah, in
specified.
many of the applications, they have mentioned the type of flexural strength as well as the strength of flexural strength of the material
Okay.
as they required.
And is there any specific standard also, ASTM standards for this one, sir? 3 and 4.
Yeah, see,
Okay.
both the having the standard ASTM D 790, okay, and for ISO it is nothing but the ISO 178.
Okay. It's a general terminology. But for 3 and 4, any specific
Yes, in that general itself they have provided that thing.
all details are okay.
Yes, okay. These
And
all are about your like we have started mechanical test today itself. Okay. So till now in mechanical test we only studied about the flexural test. Okay. In that flexural 3-point bending and 4-point bending test. Correct.
yes, sir.
So tomorrow we will see other mechanical properties like tensile. Okay.
Yes.
Tensile as well. Your tensile one, then compression, okay, in that way. Then again moving forward to the thermal properties, okay. In thermal properties, we will see thermogravimetric analysis is nothing but TGA, okay, then DSC, okay. I think Jyoti sir have took some of the part regarding thermal properties, correct?
Yeah, yes, sir.
In recent two lectures, he have already covered the thermal properties of polymer. Okay.
Yes.
So we will continue with that. So already you have studied about the thermal properties. Okay. But we will take the how that means which all instruments or which all testings have been used to characterize the thermal properties. Okay. That we will see. Okay.
Yes,
in
sir.
next lecture. So remaining part of mechanical properties, then thermal properties, electrical and other properties of polymeric material. That all things we will cover in our next lecture. Okay.
Yes, sir.
So till now, anyone is having doubt in this kind of mechanical properties or mechanical testing?
No, sir.
Okay. So we will meet in tomorrow's lecture. Okay.
Oh,
Yes.
yeah,
Okay.
yes.
Yeah. Thank you.